Okay, so I wrote a tool to fix or to help with the problem of like package management system hygiene. I guess that's the best way to describe it, which is like if I list all the packages that I have, actually, yeah, this list just keeps growing and growing and growing. And how many of these do I actually need? Sometimes I install, so some of these are dependencies, some I install just to try something and then I forgot. So fortunately, um, Arch Linux has the concept of um, the reason for installation, because I'm pretty sure I did not install that one, for example. This says the installation reason is installed as a dependency of another package. So instead of listing all the packages, I can just say like list all the packages that I explicitly installed. So this list is uh, less. All of these I manually install, but again, some of these I don't actually want, like Vulkan headers, Vulkan tools, like I installed it for some reason, then I forgot. So I found this tool, the Claro, which is somewhat what I want to do, and and it does what I used to do, which is um, something like this. I think that's what. Okay. So this is a list, and then you will like manually keep track of this list, add stuff and remove stuff, and then for example, if I add, let's add these two packages. Now what this tool will do is like generate the new list and then run this diff command, and then it says like, oh, these two packages were added. Actually more packages were added, but like for example msmtp, that was added as a dependency of another package, so it will not be appearing on that list. So the difference is exactly what I wanted, what I want to see now. Like I can edit the actually what I did, nvim diff what I did before is like I say like, okay, do I want this? Like yes, so I just added it to the list. Do I want this? No. Then I uninstall this one and then go through that process to clean up everything. Okay, so that's basically what this tool does. There's a lot of other helper commands, but this is the main one that is like a little bit tricky to do manually. But I wrote a much better tool. Well, in my opinion, it's much better. So the Claro is like a big project. Well, not big, but it's where do I have it? Then, oops, well, there's some binary stuff, but anyway, there's a lot of lines of code, 45,000 lines of code actually. Yeah, I don't know how many, but this, my solution is just um, 80, well, to 81 lines of Ruby code. and it's better. Let me show. So I just run it, and it doesn't use any temporary files, and it doesn't use any external tools. It just show me the difference, like these packages I removed, these packages I added. Actually, this is something else that the Claro doesn't have. But the main thing, well, there's at least three differences, but the one that affects me the most is that my tool sorts by size. So this, let's check. This is, what is the size? 7 gigabytes of size. So I should remove it. I just wanted to check something. I should check it and remove it. This one is 1 gigabyte, I guess. So yeah, and I don't need it anymore. So this helps tremendously, and it turns out it's not that easy, that hard to do. As I said, this is all that is needed. Just one file, this many lines of code, and there's many other advantages. Part of this video is to show this tool, but another part is to show why Ruby is so good. So I'm gonna show part of this video where DHH, which is the creator of Ruby on Rails, explain why Ruby is so great. And then I'm gonna explain this code part by part, and part of the reason why it's so simple is thanks to Ruby. So yeah, let's see.
We should say maybe like paint a picture of the certain qualities that Ruby has, maybe even compared to PHP. We should also say that there's a ridiculous thing that I'm used to that I forget about, that there's dollar signs everywhere.
Yes.
PHP.
Yes.
I mean,
there's line noise. That's what I like to call it.
line noise. Line noise. That's such a beautiful phrase.
Yes.
Yeah. So there's all these things that look like programs. And with Ruby, I mean, there's some similarities in Python there. It just looks kind of like natural language. You can read it normally.
Here's a while loop that does 5 iterations. You can literally type the number 5 dot. Now I'm calling a method under number 5, by the way. That's one of the beautiful aspects of Ruby, that primitives like integers are also
times.
objects. And you can call 5 dot
Numerator.
times start brackets. Now you're iterating over the code in that bracket 5 times. That's it.
Okay, that's nice.
That's not just nice, that's exceptional. There's literally no other programming language that I know of that has managed to boil away the line noise that almost every other programming language would inject into a 5-time iteration over a block of code to that extent.
That's a really nice. Oh, thank you for giving that example. That's a beautiful example. Wow, I don't think I know a programming language that does that. That's really nice.
Ruby is full of that. And so let me dive into a couple of examples, because I really think it helps paint the picture. And let me preface this by saying I like the ethos of Python. I think the Ruby and the Python community share a lot of similarities. They're both dynamic interpreted languages. They're both focused on immediacy and productivity and ease of use in a bunch of ways. But then they're also very different in many other ways. And one of the ways they're very different.
By the way, I completely agree. Superficially, they are similar, or you can achieve the same things, but the syntax is, to me, is worlds apart.
This aesthetically. Python, to me, I hope I don't offend people too much. I've said this before. It's just it's ugly.
Yep.
And it's ugly in its base because it's full of superfluous instructions that are necessary for legacy reasons of when Guido made Python back in 87 that are still here in 2025, and my brain can't cope with that. Let me give you a basic example. When you make a class in Python, the initializer method, the starting method, is def. Okay, fair enough. That's actually the same as Ruby, DEF, definition of a method. Then it is underscore, not one, underscore, two, init, underscore,
Yeah.
parentheses start, self, comma, and then the first argument.
Yeah, the whole self thing. Yeah.
I look at that and go, I'm sorry, I'm out. I can't do it.
Yeah.
It's everything about
That's
it
it.
offends my sensibilities to the core. Here you have the most important method that all new objects
So beautiful.
or classes have to implement. And it is one of the most aesthetically offensive ways of typing initialize that I've ever seen anywhere. And you guys are okay with this?
Yeah, you're making me, you know, where
Def,
you're like talking about my marriage or something like this,
init,
and I'm now realizing I've been in a
self,
toxic relationship all along. Yeah, I just get used to it.
why?
That, to me, by the way, was
the
the magic
problem.
of Ruby. It opened my eyes to how beautiful programs could be. I didn't know. I'd been working in ASP. I'd been working in PHP. I didn't even have the concept that aesthetics, beautiful code, was something we could optimize for, that's something we could pursue, and even more than that we could pursue it above other objectives. That Ruby is as beautiful as it is not an accident, and it's
me,
not easy.
this code
Ruby
is
itself
actually
is implemented in C.
Now I'm gonna
It's
explain it.
very difficult to parse Ruby code because Ruby is written for humans, and humans are
Right.
messy creatures. They like things in
So,
just the right way. I can't fully explain why the underscore init underscore make me repulse,
Yeah.
but
me
it
too.
does. And when I look at this question mark in here, because it just reads so nicely. If user admin question mark, that's a very human phrase, but it gets better. You can turn this around. You can have your statement you want to execute before the conditional. You
Right.
can do user.upgrade, to say you're calling an upgrade method on a user, space if space user.admin question mark. We do the thing if the thing is true. Instead of saying if the thing is true, do the thing. But it gets even better. This is why I love this example with the conditional, because you can keep diving into it. So let's flip it around. User.downgrade if exclamation point not user.admin. Right? That'd be a
Right.
typical way of writing it. Ruby
Not in
goes,
Ruby.
that exclamation point is light noise. Why do we have if and then an exclamation point? That's ugly. We could do
Yep.
user.downgrade unless user admin question mark. That to me is an
That is beautiful.
encapsulation of the incredible beauty that Ruby affords the programmer through ambiguity that is only to
Completely agree.
serve the human reader and writer. All of these statements we've just discussed, they're the same for the computer. It'll
Yep.
compile down to the same C code. They'll compile down to the same assembly code. It makes no difference whatsoever. In fact, it just makes it harder to write an interpreter. But for the human who gets to choose whether the statement comes before the conditional or the predicate method has, it's just incredible. It reads like poetry at some point.
It's also incredible that, you know, one language designer is creating that. You know, Guido van Rossum also. It's like one person gets to make these extremely difficult decisions
No.
because you have to think about how does that all get parsed, and you have to think
Almost
about
10
the
seconds.
thousands, if it's a popular language, the millions of people that end up using this, and what they feel, what that question mark on for the if statement, what does that feel like for the
That's
user?
what Matt's thought about, because he started his entire mission off a different premise than almost every programming language designer that I'd heard at least articulate their vision. That his number one goal was programmer happiness. That his number one goal was the affordances that would allow programmers to articulate code in ways that not just executed correctly, but were a joy to write and were a joy to read. And that vision is based on a fundamentally
I love
different
that phrase. Joy to
view of
write,
humanity.
joy to read.
There's no greater contrast between Matt's and James Gosselin, the designer of Java. I once
All right. So now let's look at this code. So what I'm going to do is I'm gonna start with this. Okay, actually I'm gonna delete everything. Oops. Let's start there. I'm gonna explain step by step. I will show why Ruby is so powerful and so well suited for this task. Okay, uh, let's run this. So this is listing all the files in that. Well, it's a globe pattern because there's many directories, and like let's look at to one. This one. So this is the directory, and it contains multiple files, but I'm only interested in this one, the description. So the description follows a pattern like this. So the name is of the package is this one. This is the version. This is the base, description, URL, and so on. So it's a very simple text file, which actually Ruby is perfect for parsing because many of the constructions come from Perl, which was designed for precisely this kind of task. So let's start with one. Actually, let's start with this one. So the description file is going to be this desk. Let's start with that. Then we're going to open that file. So blocks, this is a block in Ruby, everything between do and I'm going to specify the variable. I'm just going to call it file. And P is just like an inspection. It's the same thing as puts file inspect. Let's just run that. Put string. All right. So this is a file. Now, what I can do is read the entire contents of the file. Okay, so that's it. Now, I don't actually want the contents. I want to split this file in chunks. So there's a new line, and then there's a new line, and that's what separates each chunk. For example, here, this is the whole chunk. Okay, so each creates an enumerator, and instead of reading line by line, we're gonna read by chunk. Like this will be like reading line by line, and this is gonna be reading chunk by chunk. Then we're gonna do another block, and then print each chunk. That's it. Like name, version, base, description. each chunk is separated. And for example, this has multiple lines in this chunk. In fact, we don't need the file. One of the good things about blocks is that after here, like Ruby is gonna close that file, so freeze that memory. But we can chain the operations, because this is gonna open a file, and then on that file we're gonna do .each. Then we're gonna do this chunk, and at the end the file is gonna be closed. So that's it. Now, for each one of these chunks, we want to split. We want to do a pattern. So that's going to be a regular expression. Actually, I think, well, I'm gonna guess. I'm not too familiar what's the format, but chunk, something like this. We're gonna look for a regular expression where we're gonna have like a something between these two things, and then some other stuff. Okay, and then because this is multiple lines, normally it will be like this. So that's the beginning and the end. But we're gonna do beginning and end, and we're gonna put this into parentheses. Actually, let's try, no, because this is multiple lines. I was going to show it in an online regex evaluator, but I don't know if they work correctly with multiple lines. But anyway, so what I'm going to do is print number 1 and number 2. I think that should do it, but it says syntax error. So maybe it's the other way around. Yes. Okay, it doesn't work right because we are gonna have 2 new lines here. Yes. So that's it. It's splitting correctly each ID and the value, like key value. Sorry. Now, where is the depends? It doesn't seem like it matched depends. I think I had to add this to say that it's multi-line. Yes. So now it's matching it correctly. And now what we're gonna do is we're gonna add each one into a hash table. So we're gonna add a hash table, and then info, the key is gonna be the same thing as value. And then we're gonna print the hash table, the hash. So now we have name, version, base. Now it's better to, well, I want this, lowercase. So just say this is gonna be lowercase, and then I want symbols because that's more efficient. I think it's to sim. No. Downcase maybe. Yes, there we go. So basically, instead of saying info name, which is a string, it's going to be info name, which is a symbol. So a symbol is a symbol is a number, so it's going to be more efficient trying when storing and fetching the values. Now let's look at the code. How am I doing? no similarities to the original. Okay, so it's pretty much the same thing, except instead of chunk I call entry. Okay, and I use AC to say uppercase stuff. It's fine, like, and then actually it's pretty much the same thing. And I also did downcase to symbol equals to, so it's exactly the same as I wanted. Now, because I already know like what we're gonna need later, I'm gonna convert this to an object. So let's create a class. So packages equals package dot new, and we're gonna pass that hash. And we're gonna store, like for example, name is gonna be info name, right? Version is gonna be info version, and so on. So, oh, okay. Right. I did it wrong because the hash table is gonna be 1, and then we're gonna go through each entry and add the information into 1. Now we have created an object. We have the name and the version, and then we can say, like for example, let's print the name of this package, but for that, instead of creating a new function to return the internal, like this is an internal instance variable. So outside of the object, we don't have access to that, but we can say this is gonna basically do it for us. So now we can access the name instance variable from outside. But for example, version doesn't have an accessor, so if I try to access it, it says undefined method. Okay, so to access it, like it will be like this. Yeah, so now that works, but we can just say version, and that's gonna be the same thing. All right. Now, why do I want to do that? So let's look at the initializer that I created. So a name is the same thing. Version is not gonna be needed. So we have groups, depends, and as dependency. Let's remove those for now. So this is what I care about. So we want this is what we want for now. Just to have the name and the size. Okay, so now we can do this same thing, but for all of the files. All right. Let's run that, and it works. Now, let's create an array, call it packages. I mean, let's make it a hash, because I already know we're gonna need a hash. So creating global variables, I mean, it will be, this is the same thing, but I prefer to specify that the global variable, just to see that this is not gonna be local to this block. So we're gonna add the name is gonna be the key, and then the value is gonna be the object. Right, so this is a little bit hard to see, but basically we have a hash table of packages. Now, for now, I'm gonna be interested in the objects, and then we're gonna do sort. Actually, I just thought of a better way to do this, but anyway, we can say sort by the size parameter. Well, actually, let's do it manually. So here I say, like, for each, the e is gonna be each package. So this is like e in for loops. It's typical. Well, I use e when we're talking about blocks. So sort by receives a block, and this is the block that is gonna do this. Okay, so I'm gonna store it into an x temporary variable, and then I'm gonna do x each do, and again e. Just gonna print e.name and e.size, and then end the block. Let's see if that works. And here we have CUDA, ProtonG, custom. So these are sorted by the size, which is exactly what I want. And in all these lines of code. Now, this can be further simplified. For example, first, here I can say id.size. Works. And then this can be further simplified by id.size. Right? That works. In fact, I think I can create this damn it. Actually, thinking if I should Google how to do this, but I think it will be this comparison will be the same as just saying sort. Yeah. I don't know if this is easier to read than this. I think I'm gonna go for the less lines of code. So it's gonna be this one, and then I don't need a temporary variable because I can just chain and say for each do this. That's it. How many lines of code? 26. Now, we don't want to do this for all the packages, just the ones that are installed explicitly. So let's copy this. So this is gonna be a boolean that if the reason is 1, like if there's no reason, this is gonna be nil. But if the reason is 1, that means it was installed as a dependency. So here we can say next unless, no, next if the package was as dependency. Yes, but this has to be as dependency accessible. Right. It's interesting that. Okay. I don't know if I want all of this, but anyway. Okay, so at the end, I just want to print the name. All right, I just want them ordered, and I for that, to me, this is the simplest way to do it. Just create an object and then sort by a member of that object. What else? What's the next step? So let's compare the output. So if I pop if I run my tool Pactropy, I'm gonna store the output in temp A, and then let's run the test and store the output in temp B. BD is just a shortcut for nbeam D. All right, let's remove this stuff, and then let's remove from the beginning plus space. Let's remove that stuff. All right. So we have a difference. Let's look at this. Some of these, like run mirrors, exceptionally. So these are the packages that I have specified that are essential. So in the world of the Claro, there's a packages list. So that's going to be the basis for the diff, right? So now we have to implement the diff, which actually is not that complicated. But instead of packages.list, I have YAML files. So let's, for example, here is a list of packages. These are the packages that I consider essential, and then we're gonna diff like so that base is gonna be ignored and rank mirror is gonna be ignored. All of these are gonna be ignored because they are already in the list. So we want to generate a delta between this list and what is installed in the system explicitly. So that's the logic. But first, I've found that splitting into multiple files is useful, and the reason why it's a YAML file and not just a list, a text file, is because sometimes I want to specify a group instead of a package, and the logic is going to be different. But that's for later. First, let's just concentrate on the list. So I'm going to implement this manually, but first let's try to do it myself. So dir glob, we already saw how that works. Dir home is going to be my home directory, and then file.join is going to join the two things, and then we are going to add the glob pattern that we want, which is all the YAML files in that directory. Let's print each one of these. So it's going to be this, not the other ones, because I have one that is like a backup, so I don't want that to be included. Then require YAML, I think, and then YAML.load and that file. I think that's, no, it's load file. Yes, that's it. So now we have a list of packages. Packages and groups, but we care mostly about the packages. But actually, before doing that, let's assume this minimal list of packages. Actually, let's not even parse that. Let's comment this for now. And then this is going to be essential. I think that's what I called it, right? Which is going to be an array. Now I could do like this, base, Linux, and so on. But Ruby has a helper, which is for every word here, is going to create an element of the array. So let's remove yeah, like that. So if we print that, that's an array, and each element of the array is a string. Okay, so these are going to be our essential packages. So now all we have to do is say next. So we ignore the package if it's a dependency, but or essential include. I always forget if it's include or includes e.name, which is the name of the package. Let's see if that works. Okay, it did something. Let's compare the output between B and C. And now we're keeping the packages that were there. So this is what we want actually. Linux, NeoBeam, Ruby. Yeah, so this works correctly. So now all we have to do is get that from the list. From the YAML files. So we're going to create an empty array, and then we're going to add data packages. I think that should do it. Right, now let's see the difference. Now we have a delta. This is similar to what declare will do, because it will do like this, a diff, and just show the delta. So this is the same thing, except in 38 lines of code. Okay. But still, there is a difference with my tool. Why? Well, all of this XFC stuff is because of the group, but that's, yeah, maybe I should, that's the next thing I should implement. Yeah. Okay. Now, I'm going to cheat a little bit. So, for each package, we have the name and the package. Actually, this name is not used, so actually this can be cleaned up like this, or it could be each value. I think. Anyway, so we are gonna do this for every package. Now, if essential groups, so this is a union. Between the essential groups and the groups of this package. So basically, if one of the groups in this package is contained in the essential groups, then we're going to skip it. Not included, sorry. If it is part of the essential groups, then we are going to add it to the essential stuff. So first, let's not do anything. We don't actually have the groups, so before doing anything, let's print the package groups, right? And this, actually, I want to clean this, because this I think that's better. And here package is going to be pkg. This is just for later. A little bit of cleanups. Anyway, I'm not sure if I'm actually going to do that, but otherwise the code is never going to be cleaned up. Um, all right, let's run that code. Oh, right. Only if it exists. Okay. Now groups is not defined, so groups is going to be info groups. Actually, I already know that's not the case, but for now, let's do that. So it's either nil, or a string, which new line separators. So we can just convert this for each new line. We're gonna split that. Right. If it exists, this is a chain operator. Like if it's nil, it returns nil. Otherwise, it does the next thing, which is split the string to have an array. Okay, so that works. Now I have an array, and essential groups actually contains XFC. It should. Let's comment this. Yes, XFC. So let's print the name. So this one is contained in these two groups, but actually all we care about are these ones, the ones that are in XFC4. So that's what this line is doing. If the union between essential groups and groups, so essential groups can contain multiple groups, and the package groups can also contain multiple groups. So we are going to do a union, and if there's one, then we don't skip. But if it's empty, then we skip, because basically none of the groups of the package are contained in the essential groups. So now we're going to print only right. We always want to have an array. That makes the rest of the code easier. So now we have only the packages, exo, garcon, tuner. All of these packages are part of the XFC4 group, so we are going to add them to the list of essential packages. That's it. So now we have another functionality. Still, the code is relatively simple. Let's do a difference, and that's almost there. But there's a difference, and that's actually the main difference between my code and, well, it's not the main, but it's the trickiest thing to implement between me and my tool and the Claro. Now, at this point, this code is more than usable. Like, anybody can use this, and it's already like it lists the list of packages that have been explicitly installed that are not part of any of the packages in the list. Um, in the list specified, actually let's see all of these, XFCE and gaming on this file, and there is the option of specifying groups. So this is already very usable, and it's sorted by size. So I know this is the first one I should be cleaning up, then this one, and so on. But we're not done yet, because there is something else we can do. Now, why is, for example, patch being listed in this code but not in the final code? Because I installed this package explicitly, right? And it's not in any of my essential package list of essential packages. So it's going to be listing it here. But there's another package, NVIDIA OpenDKMS, that I also explicitly installed. Now, NVIDIA OpenDKMS depends on DKMS, which was installed as a dependency, and DKMS depends on patch. So I don't need to install both NVIDIA OpenDKMS and patch. I can install just one, and that's what cleans up the list of essential packages, because I don't have to install two. And this is like a trivial thing, like, do I add it or not add it? Is it okay to add two? Sometimes it is, but sometimes it's not. So it depends on the situation. But when you do this like all the time, it's nice that these kind of redundancies are removed, and it's worth to spend a few minutes of time implementing this in a few lines of code, so that in the future I don't have to think about this ever again. Now, this is the trickiest part of the code, but it's gonna be worth it, in my opinion. And I would rather do this now than keep seeing this noise that right now is not so much, but sometimes it is. Also, this is gonna show one of the most beautiful things uh, in Ruby, I think. So, thinking how should I start? So, what I'm gonna do is gonna add a method called each dep. And here, actually, yeah, let's start with just one package. NeoBeam. And in fact, instead of NeoBeam, instead of doing this for all the packages, because we're just gonna test one. Okay, so that's the NeoBeam package. As dependency, it was not installed as a dependency, and then the groups are gonna be empty. Yeah, all right. So what I'm going to do is that for each package that is part of the essential list, I'm gonna look at all the dependencies. So the whole tree of dependencies. So here I'm gonna do some stuff with dependencies. Okay, but for that I need to parse the dependencies. Okay, which is just as groups. They are divided by new lines. Okay, so I could just return the dependencies. For example, each dep, that's going to return an array. Uh, Depends. Maybe I should call it depends. Right. Right. So we have all of the dependencies, but here's something tricky because sometimes the dependency specifies the version. So I need a helper function that is going to convert that to a dependency. So here we have to do more stuff. Here we have to do a map, and for each element on the map we're going to do parse dependency and pass that. I think that will, yeah, that's basically a no op, but then we have to do something in this parse dep function. I'm just gonna copy the regex. So if it matches any of these regexes, we're gonna return the first part, which is this number 1. So this is like uh, I'm thinking this is not the best way to do it. Hmm. Yeah, I think this is better. It's a little bit cleaner. So if the dependency matches this regex, we're going to return the first element. Otherwise, we return the dependency. That's better. Okay, and that fixes. Now we have an array of only the names of the dependencies. All right. But what are we gonna do with each one of those? We could just add them to the essential uh, dependencies. Mm, Thinking how could this be done for all of the packages? Packages dot values each essential. Actually, we want an union, because if it's already there, we don't want it again. I forgot the beginning. For now, we're gonna just print the result of that instead of adding it. Yeah. So that works. Now let's see if that works for everything. Uh, it removed more stuff. Maybe I missed something. Uh, Interesting, interesting. All right. Mm. Okay, yes, it was essential. Right, right, right. We need to fetch the package. So packages, that's a good thing that we have this is a hash. So we have to do this on each package, not on each name of the package. Right? If it's found next unless package. There we go. All right, so that's better, but there's still a difference, because actually what I want is not just one level of dependency. I want to do it for the whole tree of dependencies. Now, is that going to be worth it? Let's spend some time and see how to implement this. So, first, because it's not gonna be just an array. Actually, well, yeah, let's try first doing it as an array. So the array is gonna be empty, and then at the end we're gonna return the array, and then we're gonna add to the array the dependencies, and it's the same thing. Actually, let's just do this to keep checking. Sorry, between B and C. Right, so no changes. Okay, so now we want, well, the best way to do it, like it could be done recursively. To me, that's inefficient. So let's do it with that stack. So we're gonna clone that array. That's gonna be the stack. Clone. It's dupe in Ruby. Oh, it's not used. Then stack.pop, that's gonna be our element. Then no, we're gonna add, this is in order to add a single element, we're gonna add that element to the array. I mean, this is a little hard to see, so I'm just gonna call it array. And then for the element of the array, we're gonna fetch the depends, which for that we need depends here as well. Right, and then that is gonna be added to the stack. But at the end of the stack, how do I add this +1 plus equal? Okay. Right, and then do the same again. Right, until break if e equals nil. Now, I could add this here, like until something like that. But a better way in Ruby is just to say while this. Okay, this is going should be stuck. Actually, like that. Now, E is going to be a string, so it should not be E depends. Actually, it should be the packages name package.depends. Yeah, we have to fetch each one, put it into the stack and do it again. if it is found. Now that seems to not be working correctly. Right. I know what's happening. So let's not do it for all of the packages. Let's just do it for one package. Oh, but yeah, we need to parse all of the packages, otherwise we don't get the dependencies. Like this is gonna be nil every time. All right, this works, but there's many packages repeated because we are doing it over and over. So we need a hash table in order to keep track of when we have visited a package. So right, there's going to be a temporary, like in order to keep track that we have visited a node, an element. Now that works correctly. And now we can do this for everything. Right, now patch is removed because it's going to through the dependencies. Actually, I think yeah, I created this to show more or less how, like, Whisker menu plugin depends on XFC panel, which depends on this and this and this. So it's doing something like this, like kind of recursively. So that works, that's functional. It took a little bit of fiddling around, but now it works. But here's where the beauty of Ruby comes, because this works, yes, but it's not very clean, at least to me. Okay, so let's go back. What I want, actually here, what I want is this. I want an array of names of packages. But a better way to do this instead of having a local array is an enumerator. So this function is going to do something uh, So if I do this, that doesn't do anything. I have to do each, right? Because it's an array, and then we're going to do something with each element of the array. But what we can do is do that here. So we are going to return an enumerator. Instead of returning an array, we return an enumerator, right? So with this enumerator, now we don't have to do each here. Why? What? Right, we have to pass the block. But anyway, I'm not gonna do that. I'm not actually sure what is the syntax for that. But basically, instead of doing this array, we do yield, and that's gonna pass this to this block, which is basically doing the same thing, but now we're not having an intermediary array. So this is better. But if we want this to be more extensive, like for example here I want to print the size of each package, like if I want to, this is the size of the string, not the size of the package. So instead of yielding E, I want to yield the package, right? So now I can do like more fancy stuff. E.name, E.size, for example. Okay, so that's better, but that's more extensive. But um, actually, I think this is better. Yeah, like mark it as marked it as visited, even if it's not installed. Yeah, something like that. That's better. But for our particular case, like this is more extensive for other cases, but for our particular case, we just want to show the names. So one way to do that will be each step map. Well, we could add the names to an array, but what we want is to map, and then for each one of the elements just get the name. It says no block given because yeah, basically we have to do it here. E.name. And then convert this to an array. So well, actually that doesn't even work, but right. So that's where this magic thing comes. This is like basically boilerplate. So if no block is given, then we're gonna convert this thing to an enumerator. So now if I do each step, that's an enumerator. And this enumerator, I can do map, and for each one, convert elements of every element in the enumerator, return the name. But this can be simplified as this. So now we have the same thing, except it's more extensible. This thing is like magic. It's gonna return, it's gonna do something for each element, each package dependency and all the dependencies of it. Now we can just get rid of that and then do that here. Each dep map name. So we're just gonna add each name of each dependency and the subdependencies to the list of essential packages. And that's it. Now there's no difference between my tool and this. Now let's see. How different it is in the end. Right. I'm adding here more stuff in case to show when packages are removed or added. This order is the other way around, so I actually will like it to be the other way around. So that's fixed. Okay, so now it's more similar. The groups thing should be before checking the dependencies, yes. So right, if we are gonna check the package after we check the visited, this could be moved here. Oh, and then one can be true instead of, well, the name doesn't really matter, but I'm gonna change it to dep. Okay, so that's exactly the same thing. The next thing is the order of the things, and I think I'm gonna change the order in the original tool. Now here I'm using I forget how this called, but it's like 3 values. Like if this is true, then do this. Otherwise, do this. But I think my code actually is that other code is better. Just do the chain thing. This or that, and the same thing here. change the things or do that. Actually, that's better. So this exercise already improved things. Now let's change the order. I think size is more important. That's the first functionality that we added. Groups and depends. Okay, yes. Now the essential packages, yes, the groups secondary. And now the only difference is that here I'm using symbolized stuff. So not much. Symbolize names. True. So basically we're going to change all the stuff in the strings. I actually don't know how that's mapped. Whatever. In BI, because in BI it's different, but packages is going to be packages with semicolon. That's going to make it a symbol, and the same group thing for groups. Yes. First the essential, then the groups, and that's it. Basically, now we have the same thing. That's the tool. And of course, this is better because we can just do entropy, and it's going to tell us like not just what packages were added, but the size. Like this one is the first one I will want to remove, then this one, then and so on. It's also telling us like I have this in my list of essential, for example, like the M, but I removed it. Like it's not found. So there's two things: either I install this or I remove it from the list of essential stuff. Not sure what I want to do right now, but this is something else that the original tool cannot do. So this asterisk means that it changed from a dependency to be explicitly installed. So right now, msmtp is installed as a dependency of another package. Which one? This one, msmtp mta. But I have it here as a dependency. So basically, I need to remove it as sorry, something essential. So this is not what is essential. But if we look here, there must be some msmtp. Well, let's just grab. Right, so msmtp mta was added and msmtp was removed. So actually, this is the change that I want to do. Now, packtropy doesn't like it reduced the entropy because this is what I want to install. This install the other thing as a dependency. So now all I need to do is install this, and MSMTP is also going to be installed, but as a dependency. And then I can go through the list. So now there's less stuff. Let's remove this because I'm not always interested in them. And then I keep going, like lost files. Actually, I do want there. It's useful. Not sure where to put them, but for now I'm just gonna put it here, like lost files. Now Hypershot, actually I'm gonna remove. Now Tiny XXD, it's useful but not always. I'm just gonna remove that. QEMU desktop, it's useful sometimes, but yeah, I'm gonna remove it. Yeah, that removes a bunch of stuff. Yeah, and that's it. Like that's how it works. Like now I see like Apache, PHP, FPM, and so on. I already have them here. So let's move this to actually consider them. Now there's less stuff. I'm gonna remove HG Evolve, Vulkan Tools. Mango HUD. Yarn as well. CMake, headers, CRT, actually. GCC, headers, WinP threads, bin utils. Let's remove all that stuff. And that's it. Like I keep going. Like I don't always clean everything. Like I forgot this. I added to the web development stuff. Then like Ruby Gems and RDoc, I don't want them like explicitly installed, so I should change that, but later. And then debug, edit, and fake root. These are just for packages, which I'm probably gonna add later, but right now I don't want that. Then Rust, CLang, mercurial. Let's remove bind. I don't need it right now. Autocov archive. I don't know where that came from. Benchmark, pick, zip, pack, utils. Yeah, let's remove all that stuff. Sensors plugin as well. Test unit, rake, web rig. Yes, let's remove all that stuff. Then Ruby IRB I'm not using anymore. I'm using Pry now. So I could remove it, but I remember there was a bug report, so I'm gonna leave it there just to remind myself to fix it before I stop using it. NASM Ruby RDoc. Python pip as well. Qt6 tools. Shillang. Yes. Now this one, I thought I had already added it here in gaming. This is for Steam. Actually, Vulkan Radeon as well. Maybe I should add it here. I'm not sure if I'm actually using it, but you can add comments like, okay, let's check that later. And it's now the delta is much less, and that's and that's how I go about cleaning stuff. Now I'm gonna want, like, they splitted the plugins, so let's add the VLC plugins. FMPEG and Matroshka. Yep. And so on. Like that's, I don't have to like do any diff, any extra configuration. It's just you just run the command, which is extremely simple. And if I need a new functionality later on, I can just add it into this extremely, well, for me it's really simple, beautiful code. And actually I can copy paste this and ChatGPT understands it perfectly. This one, I think, actually, I do know that I want it like this. One of these is the dependency of the other, so I don't have to specify both, but I want to. I want to keep keep them all specified. Now there's less stuff, and here it marks this as like it was something before. Now it's something different now. Yeah, so I think it's pacman. Actually, I'm just going to install it. Yes, there's a way to change it, to change the database. I think it's, no, actually I don't know. As, but the option is as depths. Yeah, it's pacman s as depths, and then NVIDIA util. I think it was like that. But anyway, oh, I still have to do it. But it's not as depths actually, it's as explicit. Utils. Nope. Oh, it's the. Now the install reason has been set to explicitly installed. So now it's not gonna show it here. And so on. Now it's much less delta. And these files actually I keep track on my own dot files. So I can just clean up my entire system. If I have my dot files backed up, I know exactly which packages to install, which is all of this. And I can keep track, like, okay, maybe I'm just gonna leave it as this today, but in a week or in a month I check again. I run pactropy, see what changed, synchronize my files here, and there will be more. There will be more packages here. Maybe there will be less here, but anyway, that's the way I keep track of the delta. So yeah, I just created pactropy, the project, but I need to add the README, explain how it works, but hopefully this video shows, like, you just add this into to your path and everything will work. Easy. All right. Cheers. Leave a like.